In nature, all interactions can be explained by either general relativity or quantum theory. Both theories have been tested independently and with extremely high precision, but it's still unclear yet if these theories interact, how they interact, and if a unification of both theories is possible. The research platform for testing the quantum and gravity interface, in short TURIS, at the University of Vienna, aims to address this question by putting together different research groups with complementary know-how to perform experiments in the laboratory to expose quantum systems to gravity.
It's very exciting because it's different cultures, although we're all physicists. Sometimes we benefit, and hopefully they'll benefit, to see things in slightly different ways, not only the experiment, but the science.
It has the opportunity to work on a lot of projects at the very beginning of their sort of experimental existence. I was very interested in seeing the proposal papers that they were working on and different ideas for what might happen. And my role here as a postdoc has been to take these ideas and translate them down into concrete experiments that we can do in the lab.
My research group will use single photons and entangled photon pairs. We have extremely high control that we put those photons into large-scale interferometers with long fibers, such that we can see different gravity effects for photons traveling closer or further away from Earth. Other research groups will use quantum systems with massive particles to observe similar effects due to gravity.
Here in the Aspelmayer group, we work on macroscopic quantum superposition of levitated solid-state object. What we are trying to do there is to prepare a levitated particle in its ground state of motion and then apply quantum control techniques to create a superposition state. If you have an object prepared in a superposition, it also means that the gravitational potential created by that object is in the state of superposition. And the natural question that we won't like to explain is, does this mean that we have to use a theory of quantum gravity in order to explain what this object is doing to other objects nearby? A research platform TURIS is a great place, great environment to do this experiment in because we have close collaboration with theoretical groups around and also with other experimental groups developing the technology together.
In our group, we study quantum reference frame under the presence of gravitational fields from a theoretical perspective. Reference frames are everywhere in physics, they are ubiquitous, and they are especially relevant for general relativity, which is the current theory of gravity, because of the relation between gravitational attraction and accelerated reference frames. At the same time, reference frames in real world must be physical objects, and therefore they must obey the rules of quantum mechanics. It is a good idea to study what would be the consequences of these quantum effects in reference frames, and this is a good way to study the interplay between quantum physics and gravity. The TURIS project is an exceptional platform for studying the interplay between quantum physics and gravitational effects, mostly because at the same time that it brings quantum community and gravitational physics community together, it also brings experimentalists and theorists together. We are constantly giving feedback each other, and this makes the work of both communities much better.
Here at the University Observatory, we're very excited about being part of TURIS. We enter the last stage of TURIS in the sense that we'll be the ones that will take the experiment from the lab to the telescope and mount it on the telescope. The idea is to have TURIS at the telescope sending single photons to a satellite and then back, and for us to measure the transmissivity of the atmosphere, the losses in photons, characterize very well the experiment and the atmosphere, including the telescope. This is, of course, critical if you want to use TURIS with telescopes in the future, so we understand exactly what is signal and what is noise. We have no idea of what we're going to find. We're not very sure. It's going to be surely not super simple, but we're very excited. This is, of course, a great opportunity for us here at the University Observatory, because we want to have single photons detectors at the telescope and use them for study stars and planets. They are experts in this technology. We hope to keep some of that know-how inside the observatory. So all in all, a multidisciplinary opportunity for us.
The long vision of TURIS is to increase the sizes of quantum systems and to increase precision to get deeper insights that hopefully shine more light on the open questions if there's unification of these two theories possible.